Right now, at this very moment, two universes are competing for the answer to the same question: can humans travel faster than light? Star Trek's answer: yes, but you need to bend space, not accelerate through it. Star Wars' answer: yes, you just jump into hyperspace. One of these answers has a complete theoretical framework behind it. The other is a single sentence and nothing more. Today, physics is the judge. The essence of science fiction has never been how big can the imagination get, it is how internally consistent can the imagination's logic be. A science fiction work with internally consistent logic is not just entertainment. It is a thought experiment, a physics hypothesis wrapped in the language of narrative. Star Trek's creator Gene Roddenberry required his writers to be able to explain how the warp drive actually works, even if only at the level of rough physical mechanism. Star Wars creator George Lucas explicitly stated he did not care about physics, he cared about myth. This is not a judgment of quality. It is two completely different creative philosophies. And when we examine these two universes under the microscope of physics, the results are more complex and more interesting than you might expect. 3 evaluation dimensions: the physical framework of faster-than-light travel, the energy physics of weapon systems, and the physical honesty of universe ecology details. The theoretical foundation of the warp drive is astonishingly close to real physics. In 1994, physicist Miguel Alcubierre published a paper within the framework of general relativity, proposing a theoretically viable faster-than-light travel scheme, the Alcubierre drive. The core concept, not accelerating the ship itself to superluminal speed, but compressing space in front of the ship and expanding space behind it, letting the ship ride inside a space-time bubble that moves with the bubble. The ship itself remains stationary relative to its surrounding local space at all times, but that local space as a whole is moving. This bypasses the restriction of special relativity. Relativity prohibits matter from exceeding the speed of light relative to local space, but it does not prohibit space itself from expanding faster than light. Cosmic inflation is exactly this. The expansion rate of space in the early universe far exceeded the speed of light, and this does not violate relativity, because what is expanding is space itself, not matter. Star Trek's warp bubble corresponds almost perfectly to the Alcubierre drive concept. The warp bubble is explicitly described as space around the ship being distorted by the warp field, forming a protective bubble, with the ship maintaining normal physical conditions inside. This similarity is not accidental. Star Trek's physics consultants, including Kip Thorne, co-author of Stephen Hawking and later Nobel laureate, participated in theoretical review of this system. The boundary between fiction and reality was already dissolving. The Alcubierre drive requires negative energy density, a form of matter that makes the energy density of space lower than that of vacuum. Star Trek's response: dilithium and antimatter power the warp drive, generating space-time distortion through warp coils. This explanation sidesteps the specific source of negative energy density, but it provides an internally consistent technical framework. The actual energy requirement, according to Alcubierre's calculations, was compressed from the equivalent of Jupiter's mass in negative energy down to approximately 500 kilograms through successive theoretical refinements. Star Wars' hyperspace jump has almost no physical framework at all. The Star Wars expanded universe describes hyperspace as a parallel dimension in which the speed of light limit does not apply. This is circular reasoning. Hyperspace can exceed the speed of light because in hyperspace the speed of light is not a limit. No explanation for why the speed of light does not apply. No explanation of what dimension hyperspace actually is. No explanation of how a ship pinpoints its exit position when it drops out of hyperspace. Verdict: Star Trek wins. The lightsaber is Star Wars' most iconic weapon, and one of its most physically inconsistent designs. Problem 1. Light cannot be truncated at a fixed length. A laser beam extends until absorbed or reflected. The lightsaber blade has a fixed endpoint in space, meaning it is not a laser beam, or it is folded back at a fixed distance by some unexplained mechanism. The Star Wars technical manual explains, The blade uses plasma constrained within a fixed length by a force field. Plasma can indeed be contained by a magnetic field, that is real physics. Problem 2. What actually happens when two plasma beams meet? In reality, they would interpenetrate or produce extreme plasma instabilities, not block each other like solid swords. Star Wars offers no explanation for this. Problem 3. Where does the energy for cutting through metal come from? The power cell inside the lightsaber hilt, at its established size, cannot store energy at the scale implied by the observed cutting performance, unless it uses some unexplained superdensity energy storage medium that the setting never accounts for. Star Trek's phasers have a far more consistent physical foundation. The phaser is described as a coherent beam of stimulated radiation amplification, essentially a laser weapon with adjustable power settings ranging from stun to full disintegration, meaning energy output is variable and controllable. Star Trek explicitly establishes that phasers draw power from the ship's main reactor, giving a complete, internally traceable energy chain. Antimatter annihilation converts to electricity which drives the phaser beam. Clear, calculable, and consistent. How much energy does the Death Star need to destroy a planet? Completely destroying an Earth-sized planet requires overcoming the planet's gravitational binding energy. Earth's gravitational binding energy is approximately 2.24 times 10 to the 32nd joules, roughly equivalent to the Sun's total energy output over 100 years. For the Death Star to release this magnitude of energy in a matter of seconds, its energy density exceeds every known physical process, including nuclear fusion and antimatter annihilation. This is a number that no known physics can support. Star Wars explanation for the Death Star: it uses a hypermatter reactor. In practice, this means we have an extraordinarily large power source. Please stop asking. The photon torpedo is considerably more credible. Star Trek establishes that photon torpedoes are antimatter warheads. 1 kilogram of antimatter annihilating with 1 kilogram of matter releases approximately 1.8 times 10 to the 17th joules, roughly 4.3 billion times the Hiroshima bomb. The warhead is specified to contain approximately 1.5 kilograms of antideuterium. That number is calculable. Comparable to real references. Physically meaningful. Sound propagating in space is the most famous physics error test. Space is vacuum. Sound cannot propagate. Star Wars: ship explosions produce enormous blasts of sound. TIE fighters have their distinctive engine shriek. Laser cannons fire with audible discharge. This was a deliberate artistic choice. Lucas believed silent space combat was emotionally inert. That is a creative decision. It is also a physics error. Star Trek in most versions keeps outer space combat scenes silent or reduced to minimal ambient sound, a meaningful difference in physical honesty. Star Wars: ships have interior gravity, but the source is never explained. In The Empire Strikes Back, objects falling from a pilot's helmet drop straight down, indicating there is a downward direction perpendicular to the flight direction inside the ship, with zero explanation provided. Star Trek explicitly establishes gravity plating as a named technology, a fictional but internally consistent concept. More importantly, Star Trek has entire episodes dealing with gravity failure, demonstrating that the writers treated gravity as a technical system requiring active maintenance, not a taken-for-granted background condition. Real space explosions do not produce spherical fireballs. There is no oxygen to sustain combustion and no atmospheric pressure to constrain the blast. A real space explosion is a plasma flash that rapidly disperses with no sustained flame. Star Wars: every explosion is a massive orange fireball identical to atmospheric detonations, completely inconsistent with vacuum explosion physics. Star Trek in certain versions shows space explosions closer to reality, a flash that expands and dissipates, no sustained fireball. Not all versions maintain this consistency, but the intent is visible. Right now I need to stop and say something important. Every comparison above has been applying the same standard to two works with completely different creative intentions. Star Wars never tried to be a scientifically accurate science fiction work. George Lucas studied Campbell's The Hero with 1,000 Faces, a book about mythological narrative structure, not a physics textbook. He explicitly stated that Star Wars is a myth set in space, not science fiction. That distinction matters enormously for how we evaluate what we are seeing. Hyperspace jumping corresponds to mythological teleportation. The Force corresponds to fate and divinity in myth. The lightsaber corresponds to the sacred weapon in myth. Within this framework, physical precision is a completely irrelevant evaluation dimension, because myth does not require physical consistency. What myth requires is symbolic power and narrative logic. Star Trek, from the beginning, had different ambitions, a work depicting humanity's future where technology must be a reasonable extension of existing physical theory, not magic given a new coat of paint. Judging Star Wars by physics standards is like evaluating Harry Potter's magical formulas for chemical accuracy. It is a fundamental misreading of the work's intent. But this does not mean the comparison is without value. Its value lies precisely in this. Through the contrast, we can see more clearly how far a science fiction work can go when it chooses to respect physics, and what it loses, and what it gains, when it chooses to reduce physics to background decoration. Both choices carry costs. Both carry rewards. Because Star Trek chose to respect physics, it produced the Alcubierre drive framework, photon torpedoes, and warp bubbles, concepts that have become reference frameworks for real physics research. NASA genuinely ran a warp ship research project, the Breakthrough Propulsion Physics Program, partially inspired by Star Trek's technical framework. Nobel laureate Kip Thorne's collaboration with Star Trek led him to think more seriously about the physical possibility of wormholes and time travel, thinking that later influenced the film Interstellar. One creative decision redirected the trajectory of real science. Because Star Wars chose the mythological framework, it achieved cultural influence stronger than any hard science fiction. The lightsaber, the Force, I Am Your Father have transcended the science fiction genre entirely, becoming part of contemporary mythology. No physics equation can calculate a story's gravitational pull on human culture. Physical rigor gives us the map to the real universe. Mythological power gives us the reason to make the journey. The universe is large enough for both. It always has been. Right now, physicist Miguel Alcubierre is still working on the drive concept he proposed in 1994. NASA is still discussing the feasibility of warp ships. Physics journals are still publishing papers on negative energy density. And one of the starting points for all of this research was a television producer named Gene Roddenberry, who decided in 1966 that his ship could not simply fly very fast, it had to have a real physical mechanism. One creative decision changed the direction of physics research.